All right, starting off here, we're going to solve these by any method. So I usually start by trying to factor first. So for number 2 here, I see I already have one side to 0. So I'm just going to do a times c up top. And so that's negative 14 and adding to negative 2. So I got to think of two numbers that multiply to negative 14 and add to negative 2. However, there's no numbers work. And this does happen quite often here. That no numbers work for factoring, and so that means I either need to switch to quadratic formula or completing the square. I'm going to use quadratic formula here because I have this a value of 2 that I can't divide all the terms by, and so whenever that happens, I can just use quadratic formula. So we'll remember quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I see that a here is... We've got a, b, and c here, the numbers in front. So I'm going to say negative 2, since that's b, plus or minus the square root of negative 2 squared minus 4 times a times c, all over 2 times 2. Negative 2 is 2, plus or minus the square root of 4. And then I know that negative 4 times 2 is negative 8, and then negative 8 times negative 7 would be positive 56, and then that's all over 4. So yeah, make sure you just multiply all three of those numbers together. So the first two, get that answer, and then multiply that by the third one. And then next up, I will go ahead and just do this addition here. So that's radical 60 all over 4. And I don't know the square root of 60, so I'm going to break that down. 6 and 10, which is 3 and 2, and 2 and 5. So of all the numbers I couldn't break down anymore, I have twin 2s. So that means we are going to have a 2 going outside. And then a loner 3 and a loner 5 are going to multiply back together inside of the radical. And then lastly, I'm just going to reduce with all three of these numbers with my heart. I'm going to divide them all by 2. And so that becomes 1 plus or minus radical 15 all over 2 now. All right, next up here, number 4. Again, I'm going to try to get one side to 0. I'm going to see if I can factor. If not, I'm going to use a quadratic formula probably. So here we go. So now I'm going to think of two numbers that multiply to a times c, which is 15, and add to negative 8. So that sounds like it will work with a negative 3 and a negative 5. So now I can do factoring, but I have this 5p squared here, which means I need to use my grouping technique. And then I'll split this up according to my x here, so that'll be negative 3p and negative 5p. And so now I'll group together this one and that one. And so for the first group, it looks like I can only take out a p, which leaves me with 5p minus 3. The second group, it doesn't look like I can take out anything, so whenever that happens, I either take out 1 or negative 1. In this case, I'm going to take out negative 1 so that it switches this to 5p minus 3, so that I have my two parentheses the same. So now I'll make one parentheses for the stuff outside, which is p minus 1, and then one parentheses for the stuff inside, which is 5p minus 3. And so that's equal to 0. So now I'm going to split this up, set those equal to 0 individually, and solve. And so on this one, I'm going to add 1, and so I get p equals 1. And now I'm going to add 3 on this one. Divide by 5, so p equals 3 over 5. So those will be my two answers right there. All right, next up here, number 6. So on this one, I'm going to add the 3 over to see if I can factor. So I get 2n squared minus 4n, and that would be minus 8 equals 0. I actually see that these can all divide by 2, so I actually want to do that first. So then I get n squared minus 2n minus 4 equals 0. So now I can try to factor multiplying to negative 4 and adding to negative 2. However, no numbers work. And so that means factoring doesn't work here. And so I'm going to have to switch to a different technique. I could use quadratic formula. But actually on this one, because I have the a as 1, I like to use completing the square. However, I'll tell you that you can also use quadratic formula. It actually always works. So it's up to you. But whenever I have that a value of 1 and if b is even, I like to use this method. So I'm going to, for this method, we actually move the number over to the other side. And then we do b over 2 squared which in this case would be negative 2 over 2 squared, which would be negative 1 squared, which would be obviously 1. So that means I'm going to add 1 to both sides here. That just tells me what I need to add. So I get n squared minus 2n plus 1 equals 5. Then I'm going to factor this now, multiplying to 1 and adding to negative 2, which is negative 1 and negative 1. So I get n minus 1 squared equals 5. And then I can square root both sides, giving me n minus 1 equals plus or minus rad 5. And then I'm going to add the 1 over. And then I get n equals 1 plus or minus radical 5. All right, next up here, number 8. So this one, I'm going to add the 1 over to see if I can factor it. So I get n squared plus 4n plus 1 equals 0. So I can think of two numbers and multiply to 1 and add to 4, but no numbers are going to work there. So I'm going to either, actually this one you can either use complete the square or quadratic formula. Either one will work. I can use completing the square because I have that a value of 1. I'll go ahead and use quadratic formula here since I used completing the square last time. But either way works kind of just as well. I'll go ahead and write it down so I can help remember it. So then I got negative 4 plus or minus the square root of 4 squared minus 4 times 1 all over 2 times 1. So we have negative 4 plus or minus the square root of 16 minus 4 all over 2. I got minus 4, it's just negative 4 times 1. And so I get x equals negative 4 plus or minus the square root of 12 all over 2. I'm not allowed to reduce that yet. I need to break this down 4 and 3 and then 2 and 2. So I got twin 2's there. So I get x equals negative 4 plus or minus 2 rad 3 over 2. And so now I can reduce all these together by dividing them all by 2. So I get negative 2 plus or minus, it would be 1 rad 3, but I just put radical 3. And technically that's all over 1, but whenever it's all over 1, I just keep the top part of it. All right, next up here, they want us to find the discriminant. So the discriminant is just the part inside the radical, so that's just b squared minus 4ac. And so we'll find that first. So we just have a, b, and c here. So b squared minus 4 times a times c. So that's 16 minus 4 times 4 is 16 times 1 is still 16. So this comes out to 0. So 0 is the discriminant. And then what we need to know is that if this is positive, it's 2 real solutions. If it's negative, it's 2 imaginary solutions. But if it's 0, that actually means 1 real solution. All right, same thing here on number 12. We want to do b squared minus 4ac for the discriminant. So that's 9 minus, and then this would be negative 12 times 2, which would be negative 24. So 9 minus 24, and that is negative 15. And anytime the discriminant comes out negative, that means that it's no real solutions or 2 imaginary solutions, because if we have 2 imaginary solutions, that means we have nothing that's real. All right, next up here, we're going to solve these by taking square roots. We know we're allowed to do this because we don't have the b value. So on this one, I'm going to divide both sides by 4. So I get r squared equals 1 over 4. And then I square root both sides. So r equals, and then since I created that square root, I have to put a plus or minus. And then for the square root of a fraction, I can just square root the top and the bottom individually. So the square root of 1 is 1, square root of 4 is 2. All right, next up here, it says state the solutions of the system by looking at the graph. So a solution on these, when we have 2 equations, is just their point or points of intersection. I see these ones only intersect 1 time there. And so it looks like the coordinates are negative 2 and then negative 3. It's right in between negative 2 and negative 4 on the y-axis. So that's it. All right, next up, we're going to solve these systems algebraically. So we're going to do this by substitution. So when I have this isolated y right there, I'm going to plug it in for y right there in this other equation. And then I'm just going to solve that one for x. Now that is a quadratic, so I want to subtract 3 over here to get one side to 0. And then I'm going to factor this, thinking of two numbers and multiply to negative 8 and add to negative 2. So that's negative 4 and positive 2. And then I'll write that out. And now I'm going to split that up and set each of these equal to 0 and solve. And so on this one, I'm going to add 4 to each side. So x equals 4. And then I'm going to subtract 2 from each side, and x equals negative 2. Now, I'm not actually quite done yet because I need to figure out what y is. However, they kind of told me here that y is always 3. And so I kind of know then that I don't really have to plug in x. I know that y is 3 because it's just kind of constant. So my answers would be coordinate points 4, 3, and then negative 2, 3 as my x, y. All right, next up, number 20. On this one, I need to isolate y first. So I'm actually going to take this equation, y minus 1 equals 2x squared minus x. And I'm going to add the 1 over so I can isolate y. So y equals 2x squared minus x plus 1 that I added over. So now that I have that, I can take it and I can swap it out for this y right here. And so I'm going to rewrite this equation as negative 2x plus parentheses 2x squared minus x plus 1, and that's equal to 3. And so you can see that what I did is I just rewrote it, but I replaced y with this parentheses over here. All right, so sometimes I have to distribute a negative there. In this case, I don't. So I'm just going to combine like terms here. I'm also going to get one side to 0, so I'm going to subtract this 3 over. So that's going to become negative 2. I'm going to combine this negative 2x with the negative 1x. That makes negative 3x, and then my positive 2x squared will go there. This is all equal to 0, so now I'm going to factor. Think of two numbers that multiply to negative 4 and add to negative 3. So that's negative 4 and positive 1. However, since I have this 2x squared here, I need to do my grouping technique. So I'm going to split this up as negative 4x and positive 1x according to this. And then I'll put that negative 2 out there. And so now I'll group it up here. And so the first group I can take out 2x, leaving me with x minus 2. The second group, it looks like I can't take out anything, so I can take out a plus 1 there. So I get 2x plus 1 for the stuff outside, and then x minus 2 for the stuff inside, equal to 0. Now I can split these up and set them equal to 0 individually and solve. So for this one, get x equals 2. This one, get 2x equals negative 1, and so x equals negative 1/2. All right, and so that's my x values. However, in this case, I need y values as well. So I need to take these x values and then plug them into whichever equation looks easier. Now I think that this equation looks a lot easier, so I'm going to go ahead and use that one to figure out my y values. So I'm going to take my x's and I'm going to plug them in for x in this equation. And I need to do it twice, once for each of my x values that I got. All right, so now I'm going to use these to find y. So on this one, I can cross cancel, and it actually turns into 1 plus y equals 3. So I can subtract the 1 over, and I know y equals 2. On this one, this will be negative 4 plus y equals 3, so I'm going to add the 4 over, and y equals 7. My points here will be negative 1/2, comma 2. And then on this one, it is going to be 2, comma 7.